Let's kick things off with a simple demonstration. You might be wondering if the footage looks like some strange effect or filter applied to a regular camera, but that's not the case. This video was actually captured using a special thermal camera, Xinfrared P2 Pro. Now let's compare the same scenario recorded with a normal camera and a thermal camera. In the view from the normal camera, we see water being poured from one glass to another. Other than that, can you notice any details about the water in these three glasses? They all seem pretty similar to our eyes, right? But when we observe the footage from the thermal camera, the color of each glass appears different. This footage was captured using the InfiRay P2 Pro thermal camera. Typically, cameras take pictures similar to what our eyes see, focusing on visible light. However, thermal cameras operate differently. They can detect details that our eyes miss by capturing infrared radiation. This allows thermal cameras to reveal temperature variations in objects. Here I have an InfiRay P2 Pro thermal camera imager. Let's crack this open and see what the InfiRay P2 Pro thermal camera is all about. Product introduction. Handy pouch. Warranty certificate. After all, this is our thermal camera. This thing is tiny. It's about the size of a large thumb drive, making it incredibly portable. And what's really cool is that it comes with a magnetic macro lens. They've mentioned that with this lens, we can observe components as small as 0.25 millimeter with crystal clarity. That's pretty impressive for such a compact device. The all-metal construction of this device feels incredibly sturdy. Despite its robust build, it weighs just 9 grams, making it extremely lightweight and easy to handle. Plus, it comes with its own pouch for convenient carrying. When tucked away in its pouch, it practically disappears in your pocket, adding to its portability and convenience. To use this camera, you'll need to connect it to your mobile phone. It's available in a Type-C compatible version for Android phones, supporting Android 9.0 and above. You can connect it to your phone either using the extension cord or by directly plugging it into your Android mobile phone. This versatility makes it easy to use with a wide range of devices. Before we begin, the first step is to download and install the P2 Pro app onto your device. Simply head to the Play Store and search for P2 Pro. The app is lightweight, just 20 MB in size. Once you've found it, wait a few seconds for the download and installation to complete. Now open the app. It will guide you through some introduction slides and finally ask you to accept the app agreement. Once you've done that, it will prompt you to connect the device and turn on the OTG data exchange on your phone. If everything is set up correctly, the camera will unveil the world around you in a whole new light. You'll witness details that were previously invisible to the naked eye. It's like seeing the world through the eyes of mosquitoes, vampire bats, bed bugs, and various species of snakes and beetles. This experience is truly eye-opening and will revolutionize the way you perceive the world. Let's take a closer look at how a thermal camera works. Every object we encounter in our daily lives emits thermal energy in the form of infrared radiation. This invisible radiation contains valuable information about the temperature of the object. Unlike visible light, which our eyes can detect, infrared rays are outside the range of human vision. Therefore, we rely on specialized infrared sensors to capture and interpret this thermal data. When infrared radiation strikes the thermal sensor, it is absorbed by the sensor's material. This absorption generates a tiny electrical signal proportional to the intensity of the infrared radiation. Let's consider an example. Imagine a simple object with distinct temperature zones. To understand how temperature is distributed throughout the object, we must use a thermal camera as these temperature variations are not visible to the naked eye. This object emits infrared radiation, with the intensity of this radiation corresponding to the temperature of each area. We can utilize a thermal camera equipped with an IR sensor array to capture these radiations. Each sensor within the array generates an electrical signal in proportion to the intensity of the IR radiation it detects. Let's assume specific values for demonstration purposes. These electrical signals are then fed into the camera's software for processing. The software interprets the processed signals, deriving temperature values for each area. These temperature values serve as the basis for generating a thermal image, allowing us to visualize the temperature distribution across the object. A thermal image, where different colors or shades represent different temperatures. The InfiRay P2 Pro thermal camera is at the forefront of this technology. It features a high-resolution sensor array comprised of 256 by 192 individual sensors. These sensors are designed to detect and measure the infrared radiation emitted by objects. Each sensor generates a distinct electrical signal based on the temperature of the area it detects. Once these signals are generated, the camera's software processes them to reveal temperature variations with exceptional detail and accuracy. This allows users to capture precise thermal images and accurately assess temperature differences in the observed scene. With a total of 49,152 pixels, or 49.15 kilopixels, the InfiRay P2 Pro offers exceptional resolution, ensuring that even the smallest temperature variations are accurately captured. Furthermore, the camera operates at a rapid frame rate of 25 times per second, enabling it to continuously update temperature readings in real time. This combination of high resolution and frame rate sets the InfiRay P2 Pro apart from other products in its price range, making it ideal for applications where precise temperature monitoring is crucial. In summary, the InfiRay P2 Pro thermal camera offers unparalleled performance and versatility thanks to its high-resolution sensor array, fast frame rate, and wide temperature range. I'll show you some applications and use cases of this thermal camera. One of the coolest features of this thermal camera is its night vision capability. Here it's around 6:30 p.m. on a rural road in Sri Lanka. On the left, we have footage recorded using a mobile phone. Due to insufficient lighting, things aren't very clear. However, when we compare this with the footage from the thermal camera, the thermal vision reveals what's really happening in the background. If you want to observe things in complete darkness, such as searching for wildlife at night, tracking lost pets, or identifying potential dangers like avalanches, this thermal camera proves to be an invaluable tool. Its ability to detect thermal radiation allows you to see clearly even when there is no light available, making it ideal for various applications in low light or dark environments. Another valuable application of thermal cameras is circuit inspection. For electronic professionals, it's crucial to analyze the heat dissipation of components to identify potential issues or optimize performance. Now, let's examine the heat dissipation of the Raspberry Pi 3 Model B. This device isn't powered on yet, so the red areas you see aren't indicating hot surfaces. They're just reflective metal covers. Let's go ahead and power it up. Can you spot 3 components getting hot? Let's take a closer look through our macro lens. The macro lens enables us to get a closer look at the components. This step-down DC-DC converter I see is hot. This is the quad-core processor. It is glowing red hot. The third component is this Ethernet interface IC. It is also hot. This is an Arduino Uno board. Let's inspect its heat dissipation using the macro lens. There are a few hot components here. This is the ATmega32 U4 microcontroller. And this is the buck boost DC-DC converter, which is also heating up. Now here's something interesting to note. This onboard LED connected to pin 13 is currently blinking. But in the thermal camera, we can see another component blinking as well. This is the resistor that connects to the power. When the LED is on, current passes through the resistor, causing it to heat up. When the LED is off, the resistor cools down again. A thermal camera is incredibly useful for projects related to heating, ventilation, and air conditioning. Take a look at this concrete slab. It may seem ordinary, but when we inspect it using our InfiRay P2 Pro thermal camera, we can clearly see a high temperature area on the slab. This is likely due to direct exposure to the sun. Now, if we're trying to air condition this room, we need to pay special attention to adding thermal insulation to this area. Without the thermal camera, this hotspot might go unnoticed, leading to increased electricity costs to cool down the room. Thermal cameras help us identify areas that require insulation or other interventions to improve energy efficiency and save costs in HVAC projects. We've covered just a fraction of the many applications of thermal cameras. From building inspections to wildlife observation, the possibilities are endless.
That's all for today. If you think my contents are valuable to the world, you are welcome to join my Patreon community. Like and subscribe to Professor Mad for more interesting videos.